Yes, very good evening to everyone. That's right. Do you have any questions about earlier classes? Yeah,
Sir,
Pandey.
yesterday class recording రాలేదండి.
I'll share. See, I will not share all the videos because of certain reasons. So if somebody will miss out the class, I'll share the videos actually.
Venkat, are you sharing any notes for yesterday class apart from that video? Hello.
See, I'm sorry to everyone. See, my son was crying. That's the reason I just couldn't speak to you. Right. So I told that the bitwise operators are used to apply for the information security for encryption, decryption. So let's suppose, yeah. So I'm going to take a, let's suppose, user ID, the computer, the net banking user ID is going to become a 65. The password is going to become a 15. So here the 65 is the ASCII value equivalent to the user ID. Password is 15. Just let us assume. Now let's print, if you perform the user ID on Bitwise operator is between password and user ID, you will be get, the output, what? 1 will be the output. So obviously I told that, how 1 is going to become, let's suppose, an equivalent binary value for the 65 we are going to take 1, 0, 0, 0, 0, 0, 1. And 15 is 1, 1, 1, 1, 0, 0, 1, some 0. Now if you perform the bitwise, AND operation, true and true will become a true, false and true will become a 0, false and true will become a 0, false and 1 will become a 0, 0 and 0 will be 0, 0 and 0 is 0, 1 and 0 is become a 0. Therefore, so the equivalent binary value will be 1. So this is going to be passes through the network. There we are going to use bitwise AND operation to conversion of a data into a binary equivalent data for encryption, which is to generate ciphertext. This data will be passes through the network. Hacker cannot understand the purpose of this particular value. Yeah. So now similarly, I'll be performing print user ID and password. Now it's not an AND. This is going to be a OR. Now you see the output. 79 will be the output if we perform the bitwise OR operation. How exactly will it happen? The same thing. 65 equivalent is going to be a 1, 0, 0, 0, 0, 0, 1. 15 is 0, 0, 0, 0, 0, 0, 1. Sorry. 1, 1, 1, 1, 1. Now if we perform the bitwise OR operation, what happens here? You have to understand that now we are performing bitwise OR operation. True plus true will become a true. False plus true will become a true. False plus true will become a true. False plus true will become a true. And false plus false is 0. False plus false is 0. So true plus false will become a true. Now if you look at this is equivalent to 64. This is going to be my 8, 4, 2, 1. So 64 plus 8 plus 4 plus 2 is going to become what? 79 is going to be a equivalent value whenever you perform the bitwise OR operation. Right? Now, similarly, We have another type of an operator is that print UID exclusive operator password. Now I would like to tell you one important point. Exclusive operator produces true as output when inputs are dissimilar. What does it mean? If inputs are dissimilar, means different, output will become true. In case if inputs are same, which produces false as output. So the behavior of the exclusive operator is look like electrical switch, where the switch will expect positive, negative, or positive or neutral. If in case negative, negative, bulb is not going to be enabled. If positive, positive, bulb is not going to be enabled. So same logic. Now what happens, you see, what is output you are going to get for the exclusive? The output is going to get, you know what, 78. What is the output of 70? Now exclusive of 78. How it will be happen? The same thing, isn't it? So 1 0 0 0 0 1 0 0 0 1 1 1 1. Now if we perform the exclusive operator, now here one inputs are same, 1 inputs are same, therefore 0 will be the output. Next, inputs are different, 1 will be the output. Inputs are different, 1 will be the output. Inputs are different, 1 will be the output. Now 0, 0, 0, 1. Now what is the output of this? This is the output of exclusive operator. Now if we count, the last bit will be 64, 8, 4, 2. So totally 78 is going to become output according to the exclusive operator operation. Do you have any questions?
కొంచెం పైచామలో చెప్పరా సార్ కొంచెం
పైచాంలో అది కామెంట్స్ రాయడము ఏదైనా థియరీ రాస్తే చాలా స్లైట్ గా కనిపిస్తుంది, అందుకోసం పైథాన్ లో రాయట్లేదు. ప్రోగ్రామ్స్ వచ్చినప్పుడు చెప్తాను నేను, దాన్ని టెన్షన్ పడకండి.
ఓకే సార్.
రైట్. సో నౌ lastly we have the another type of an operator is that left shift operator. So left shift operator is the alternate to the multiplication operator. Let us now x equal to 20. If you print x into 2, if you print x less left shift 1, if you perform the left shift once or if you perform the multiplied with 2, both will produce the same output. You see, therefore left shift operator will be used as an alternate to the multiplication operator. Now let me print multiply x into 4, left shift twice, same output. Multiply with 8, left shift with thrice, same output. Left shift with 16 and multiplied with 4, same output. Therefore, how it will be happen? Left shift means what? Now, what I'll do? I'll be taking a binary equivalent value of a 20. Now 1 is a 16, 8 will be the 0, 4 is 1, 16 plus 4 is 20, 2 is a 0, 1 is a 0. This is the equivalent binary value for the 20. Now what I'm doing here, hello, yes. So now what I'm doing here, I'm shifting only one. If you perform the x, actually it is the x equal to 20. What I'm doing here, I'm applying x left shift 1. Means what? We are shifting the bits left hand side once. So that what happens here? It will be start from here.
సార్ కొంచెం ఈ బిట్వైస్ కన్వర్షన్ 20కి చెప్పరా ఒకసారి మీరు రాసిన 20కి x ఈక్వల్ 20కి కన్వర్షన్ రాశారు కదా సార్ ఫార్ములా 10100 అది ఎలా
This
వచ్చింది
is
సార్
2
ఫార్ములా
power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4. So the position of this 1 is 16. Position of this is 8. Position of this is 4, 2, 1. So 16 plus 1 will become a 20. So positions like, decimal positions we are going to count. Rest of the positions are going to become a 0. Now, if you shift once, it will be come to here.
Okay.
The position of 0 will be moved to here. So the 0 will come to here. Now, this position, this 1 is going to come to here. So now that comes to here. This 0 will be comes to here. So it is a 0. This 0 will comes to here. This is going to be 0. Now this location is empty because all the bits are shifted left to the 1's position. So according to left shift operator, whenever the vacant position will be there, that is going to be pushed with a 0. Now if you look at this, the position of this is going to become a 32. This is going to be a 16. 32 plus 8 will become a 40. So therefore, x became 40. X became 40. Once if you left shift. Again, if you left shift twice, what happens? This 32 will become moved to the position is called as a 64. 64. So obviously 64 plus what is going to become here? This one will become to the next. This is going to be shifted twice. Next, if you shift twice, it will become 80. Again, if you shift thrice, it will become a 160. It is keep on going. I hope already shown to you. If you become 4, it will become a 320. If you become 5, it will become a 640. Like that, it will be keep on increases. So whenever whenever multiplication sequence is binary weightage, then obviously we'll be applying left shift operator. It's an alternate operator. If you want, you can apply. At electronics level, most probably, whenever this binary sequence application multiplication is required, instead of multiplication, we use apply left shift operator. Now, let me go with the right shift operator. So what I'm saying is that this operator is used to replace division operator. Whenever you require binary sequence of division. Let's suppose x equal to 20. Print x divided by 2. Print x right shift 1. You see the output, both will produce the same output. 10.010. So right shift operator is equivalent to division operator. Now, if you perform x is divided by 4, x is divided by 2, means x is right shift to 2. What happens? 5.05. Same output. Now, divided by 8, divided by, right shift thrice. It will become 2.52. Means here it will be taking rounded value. Only integer portion is going to be taken whenever you perform the right shift operation. Right? So now if we perform 16, it will be 4. 1.251. So how exactly it will be happen? You know that. Let me show you. 20 equivalent value is 1, 0, 1, 0, 0. If you perform the right shift, this bit is called as a LSB bit, least significant bit. This is MSB bit, most significant bit. Whenever you perform the right shift, this particular rightmost LSB will be discarded. Then obviously this 0 will be comes to here, this 1 will comes to here, this 0 will comes to here, this 1 will comes to here. So the output will become what? 1, 0, 1, 0. So now this is going to become what? 10. This is a binary equivalent value for the 10. Again, if you perform twice, 2 times if you perform the right shift, what happens here? This 0 will go off. Remaining is what? 1, 0, 1. It is going to become what? 5. This is equivalent to right shift once, right shift twice. Again, if you perform the right shift, this will go off. 1, 0 left over, which is going to be 2. Again, if we right shift, only 1 is left over, it will be a 1. Again, if we right shift, 0 will go off, it will become. Now you see, 5th time you are going to right shift. (32). So 0, 0 will be the remaining. The integer portion will be given as output. Right? So In some cases, wherever the division is possible with the binary weightage, we apply with the right shift operation rather than the division operation. Yeah. Right. Now, the lastly, we have a last operator is the tilde operator. This is going to be a 2's complement operator. 2's complement equivalent operator. Now x equal to 10. Now if you perform x, it will be produces that, you know what? Minus 11 as an answer. Minus 11 as an answer. What does it mean? What exactly happens is that it will be taking 1, 0, 1, 0. If you perform the 2's complement in LSB, it will be add one value. 0 plus 1 is 1, 1, 0, 1. If the most significant bit is 1, it will be a negative value. So therefore, 1, 0, 1, 1 will be is equivalent to minus 11. Because the position of this is 8, 2, 1. 8 plus 2 plus 1 is going to become 11. Minus 11 is an answer. Minus 11 is an answer. Am I clear, everyone? See, these are the operators are specifically applied in specific situations. So if you have any kind of a requirement, you can apply. The basic functionality of these operators are like at an electronics level, we apply this kind of application operators. I think so. With this operator, all the operators have completed arithmetic, relational, assignment, logical, membership, identity, bitwise operator. So if you have any questions about all the operators, you can ask me so that I'll close. I'll be clear your doubts and I'll go with the next concept. Do you have any concepts? Do you have any doubts?
Sir, hello.
Yes, yes, yes. Rajesh.
Rajesh sir. Sir, ఇప్పుడు ఆపరేటర్స్ ఇన్ పైథాన్ అయిపోయింది కదా, సో డేటా సపోర్ట్ ఆఫ్ పైథాన్ అది క్లాస్ అయిపోయింది కదా.
Rajesh, I'm not able to hear your voice properly, Rajesh.
డేటా సపోర్ట్ ఉంది కదా, డేటా సపోర్ట్ బై పైథాన్ అది అయిపోయిందా అని అన్నాను.
Can you speak other people? రాజశేఖర్ నువ్వు ఏదైనా మాట్లాడు, నాకు ఈయన వాయిస్ సరిగ్గా వినిపించట్లేదు.
అవును వెంకటేష్, నాకు కూడా వినిపించట్లేదు.
నీ వాయిస్ మంచిగా
నా వాయిస్ క్లియర్ ఉందా?
yes yes
Okay.
absolutely fine. రాజేష్ వాయిస్ నాకేం వినిపించట్లేదు.
మేబీ నెట్వర్క్ ఇష్యూ.
లేదు సార్, రాజేష్ అడుగుతున్నాడు డేటా సపోర్ట్ ఆఫ్ పైథాన్ అయిపోయిందా లేదా అని అడుగుతున్నాడు.
నో 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 డేటా టైప్స్ అయిపోయినాయి కదా, 9 టైప్స్ చెప్పాను కదా డేటా టైప్స్. న్యూమరికల్, స్ట్రింగ్, బూలియన్, కాంప్లెక్స్, నన్, బైనరీ, ఆక్టాల్, హెక్సాడెసిమల్ డేటా టైప్స్ అయిపోయినాయి కదా. ఫస్ట్ క్లాస్ లోనే చెప్పాను అవన్నీ.
ఓకే సార్, ఓకే. కొంచెం రికార్డింగ్ చేసి పంపించండి, నేను ఒకసారి చెక్ చేస్తాను, చూసుకుంటాను సార్.
రాజేష్
అదే సార్ రికార్డింగ్ పంపించమంటున్నాడు, చూసుకుంటాడు.
చూసి పంపించాను రాజేష్ నేను. ఐ థింక్ నువ్వు కంప్లీట్ గా వినలేదేమో. 2 రికార్డింగ్స్ పంపించాను. 1 సెకండ్.
ఓకే సార్, నేను ఒకసారి చెక్ చేస్తాను.
సరే కొత్త గ్రూప్ పెట్టండి సార్, మొత్తం రికార్డింగ్స్ అన్ని సార్.
సార్
Yes, yes, Vijay.
అప్పుడే కొంచెం